in the session 1, day 4 of AICTE sponsored STTP on simulation with Matlab from device to circuit. And today we are having an eminent speaker, Dr. Sriparna Shaha. Dr. Shaha is currently working as an assistant professor in the Department of Computer Science and Engineering of Maulana Abdul Kalam Azad University of Technology of West Bengal, India. Early in her career, she received her ME and PhD degree from Electronics and Telecommunication Engineering Department of Jadavpur University, India. She was associated as a faculty with Jadavpur University. She has more than 7 years of experience in teaching and research. Her research area includes artificial intelligence, image processing, machine learning, etc. She has over 70 publications in international journal and conference proceedings. She is the author of a book on gesture recognition published by Studies in Computational Intelligence, Springer. Her major research proposal is accepted for startup grant under UGC Basic Scientific Research Grant. Now I would like to request Dr. Sobbosati Sen, Dean Research and Development, JISCE College of Engineering, to welcome today's speaker. Please, sir.
Thank you, Tanmay. Thank you all the participants for your overwhelming participation over the past few days. Only 3 days are left over, and first 3 days was all highly fruitful discussion. I have been part of the few of the discussions. I have seen yesterday's solar cell session was also highly absorbing because I personally work on those areas. So today we are having Sriparna Madam with us, Dr. Sriparna Shaha, and Tanmay has wonderfully introduced Madam. Madam has been extensively doing her research work, okay, in the field of computer science and engineering areas mentioned by Tanmay. So all of us are eagerly waiting to hear from Madam. So on behalf of the organizing committee as well as on behalf of the institute itself, we cordially welcome you, and I hope the next 1.5 hours will be highly fruitful. Over to you, Tanmay.
Okay, thank you, sir. And also, we are eagerly waiting for your presentation, ma'am. Now it's time for you. Please deliver your presentation. Please, ma'am.
Thank you so much. Thank you for this wonderful presentation. So I'll be starting the screen sharing. So if you are anywhere, if you find the bandwidth issue, please let me know. At that point of time, I will switch off the video. So my today's lecture on this particular day, that will be on sensor-based gesture recognition using Matlab. So what is it specifically? We are going to, or we are trying to find out how gestures can be recognized using some sensor, and after the recognition of certain components of the gestures by the sensor, how that can be processed, that will be discussed using Matlab. So these are the basic contents of today's talk. First, we'll be talking about what is gesture, how that can be applied in today's world. Then how the gesture can be recognized using Microsoft Kinetic Sensor. After that, one particular real-life application we are going to concentrate today. There are several or numerous applications of gesture recognition. Just one particular application, due to the time constraint, we are going to talk. Then how that can be implemented using Matlab, that will be our next topic of discussion today. So first, we are going to talk about the basics of gesture recognition. So we are going to recognize gesture. So what is gesture? Gesture is basically any sort of non-verbal communication that we express to express our emotions to the other party, and this expression of our emotions using these gestures, that can be, or that does with the help of movements of our hands, a movement of our eyeballs, our total body language. Basically by that we communicate. And sometimes using the legs as well, we communicate with our emotions. Like someone is very nervous, so that is rapid movement of the leg, it might symbolize that. So gestures is any very anywhere in, like gaming platforms, that traffic signal controlling, everything is about the gestures. So gesture is the body movement as well as the facial expression. So that's basically the gestures. So these gestures can be of several types. One is the intrinsic or non-conveyed gestures. Like someone is thinking about certain solution, someone is anxious, so that is finger biting. But this type of gesture that we are not trying to actually convey, but due to our body language, it is being expressed. So it's non-conveyed gesture. We are not willing to show our emotions at that point, but it has been conveyed. So these are the one type of gesture. Other than that, another type of gesture, like while we are trying to express our thoughts, our feelings, like we are happy, we are angry, we are sad, different type of emotions where we are trying to express, that is extrinsic or communicable gestures. So these are the two broad categories of gestures. Rather than that, these two broad categories can again be segregated into different types of gestures can be there. And if someone of you are interested in this particular domain, you can concentrate on one particular type of gesture, then you can go for the gesture recognition. So for any type of gesture, how that gesture is going to be or is now currently expressed, that we need to understand. If we can understand that the body movement or the facial expression, then from that we can extract certain features, then we can do the classification. So this total process is the gesture recognition. So we have talked about gestures, we have talked about gesture recognition. Now let's talk about the applications of gesture recognition. It's like in today it's everywhere. Like if you have seen different ads, there are certain television ads are there, that is by moving your hand the volume of the TV is going up, or the air conditioner system is going to give you much more cooler air by showing certain gesture. Or like in your mobile phone, in your Android phone, if you just do this type of thing, that is the image getting zoomed. These are the different application areas of gesture recognition. So that areas can range from robot control, coordination, gaming, like what we play in different type of Sony systems are there, Microsoft system are there, that is the home. Different person has gaming consoles at their home, and they play badminton with the computer by having their body gestures. So these are the gaming applications. Other than that, you can have application in the healthcare domain. Suppose someone gets ill, that person fault, that's for the elderly healthcare, we can have gesture recognition application. Other than that, in this pandemic area, we are all confined at our home. Suppose someone wants to learn e-learning of dances, how that person can do that learning of dance by staying at his or her home, they can have the help of gesture recognition. So there are several numerous areas of application, just few are mentioned over here. So if anyone is interested, you can go to this particular book where we have delved into the different areas of gesture recognition. You can find this particular book and you can study this to understand what is the different areas or how vast the gesture recognition application areas are there in today's world. So this was all about gestures. Now we are going to recognize the gesture using a particular machine, or it's a sensor that's basically developed by Microsoft. And this particular sensor is known as Kinetic Sensor. So if someone has gaming console in their home, you can find this particular sensor along with another gaming console that is connected to your TV. So it's basically a parts of the gaming console. This is basically where the processing or the recognition of the gesture can be done. So this particular sensor, as the name suggests, it came from the word kinematics. What is the meaning of the word kinematics? Kinematics means movement of a human body. Kinetics. So this particular thing that is going to capture the movement of human gestures. How it can do that? It has a vision camera. That's basically the RGB camera. So this is the vision camera or the RGB, that is red, green, blue. These are the three basic colors. If someone is interested in image processing, you know that these are the three basic colors here. So this is basically the vision camera. Then by that vision camera, it captures the RGB image or what we call the photo in whenever we capture by our mobile phones. That's basically the RGB image we have captured. So that type of information can be captured by this RGB camera. After that, there are two IR sensors are there. So what's the principle of IR? It basically works in the principle of time of flight. Time of flight means there will be an IR emitter. It emits the IR. So it will goes up to somewhere where the person is there. Then it will be reflected back and again comes to the kinetic sensor. So this is the IR emitter and this is the IR receiver. So IR has one particular frequency, that is this particular kinetic sensor knows that in which particular frequency it is emitting the IR, that is infrared. Now it will goes to that surface and then reflect back. Though the kinetic sensor knows how much time it is taking, so it can measure the distance. So it has the velocity, it has the time, so you can calculate the distance. That's basically the principle of time of flight. So there are two IR sensors, that is basically IR emitter and IR receiver. So these are the basically three things. By that is the RGB camera, IR emitter and IR receiver. Based on this, we capture the human body in the skeletonized form. What is the skeletonized form? We are just coming. So apart from these things, the kinetic sensor, it has a LED that you can see here, that is light emitting diode is there to just show whether the kinetic is getting proper light or not. Now this is about the body gestures. Now if someone is interested about voice gesture, so the voice commands, the NLP systems you have like Google Assistant, Alexa, these are the things you have. You can ask that, hey Google, what's the temperature today? So this is known as the voice commands, and if you are interested to recognize the voice gesture, you need the help of multi-array microphone. So by that microphone, it can capture the voice gesture. Then it can process. So voice gesture have different sorts of features. So that's a different, totally different area of research. Today will be what we are going to discuss. That's about that going to take the help of this RGB camera and the IR cameras. Now, here is that a motorized tilt. Why is that? If it cannot capture the human in a proper way, that is some part has been occluded from the viewpoint, right? Or there is like some part has been omitted. So then it can adjust, the kinetic sensor can adjust its cameras such that it can capture the human body full, total capture can be done. So that is by that, for that reason, motorized tilt is. So this is the setup we have while we are working in the Jadavpur University lab under the guidance of Professor Amit Konar. He was my mentor, and under his excellent guidance, we have this kinetic sensor over there. So this kinetic sensor, you can see over here, kinetic sensor is connected to the CPU, and here in this screen the different outputs of the kinetic sensor that has been displayed. So this is the RGB image, or it's just one particular frame we have shown. So we are talking about image. It basically captures the RGB video. So this is the RGB component, and how it is being captured? It is being captured by this RGB camera. Now it has IR emitter. So you can just closely look at this particular point. You can check over here. Light is emitting. You can just check if you someone can look closely over here. You can zoom the screen. You can check that this is the light emitting. So that basically the IR emitter, and this is the IR receiver. Based on that, depth of the subject is being captured. So this is the depth, and RGB camera and IR camera, along with both of the two, we can capture the skeleton of the human subject. So this is the total setup of the kinetic sensor. So this kinetic sensor you can easily purchase from any online apps like Flipkart, Amazon, everyone, and the price is very negligible. If anyone is interested, you can find. Other than that, different data sets are already available in the internet. You can find over there also, and then you can start working on the gesture recognition. So we have talked about the skeletons of the kinetic sensor. So this is the skeleton of the kinetic sensor. So we have kinetic 360. So just take this particular image, you can have that is Xbox 360. This is basically the older version we have. So in this older version, 20 body joint coordinates have been captured in 3-dimensional space. These are the 20 body joint coordinates, like head, shoulder center, hand, left, right, wrist, in this fashion. So from the leg portion, we have foot, ankle for left and right both sides. So these are the 20 body joint coordinates that have been captured from each particular frame. One frame, 20 body joint coordinate, and each body joint coordinate has 3 dimensions of data. 3 dimensions, X, Y, and Z. From where we are getting the X and Y? So X and Y are captured by the RGB camera. So it has the information of that. It's the image. So from that you can have the X and Y coordinate. And what is the Z? Z is the distance of the subject from the kinetic sensor. Like from here, how much far the Z. So that now you opposite can captured something what direction? No, so that is anything that side of the. So that Z direction or the depth direction will always have positive value. Z value can never be negative. So Z is always positive 1. So Z value we have the positive, and the X and Y. X and Y can be positive as well as negative. Why? The coordinate of that is a 0, 0, 0 point of the kinetic sensor is here in the middle. So if someone goes in this direction, it can be positive, in the other it can be negative. For the x-axis, for y-axis, it can be positive, and it is the negative one. So like this way, x and y coordinate values can be positive as well as negative, and the z coordinate value will always be a positive one. So this is all about how the skeleton can be recognized by the kinetic sensor in the theoretical basis. So now we'll be going for the real-time demonstration of kinetic sensor. So it's this particular point, if anyone have any sort of doubt, you can just unmute yourself, or whatever be the policy the organizers have, or you can write it in the chat box. Anyone, any doubt you have currently, or we'll move to the real-time demonstration of this kinetic sensor. So if you have any doubt, you can write it in the chat box, or other than that, I will request my research scholar Ahuna Ghosh Can you hear me? You can just start the screen sharing. Yes. So you can just check in the screen of the Opona. This is the kinetic sensor we are talking about, and you can check that is the light is being emitted. So that is the particular point of the IR emitter. And beside that it has the RGB camera, and then beside it is the IR detector. So this is the actual look of the kinetic sensor. Okay, so Ahuna, you can switch off the video and start the screen sharing, and just show the real time of the gesture recognition that can be done using the Microsoft Kinetic Sensor.